Hello dear students, today I will discuss about linear differential equation of first order. Okay, so linear differential equation of first order, this is the last type of differential equation of class 12th. Okay, there are only three methods for finding solution of differential equation, first order and first degree. First is variable or separable form, then homogeneous differential equation, and then linear differential equation. Linear differential equation is very interesting and very easy to solve. Okay, so first of all, for solving differential equation, what we do? Just find the value of dy upon dx. This function of x and y. Clear? Function of x and y. If this function can be separated as a x, function of x and function of y, then separable form, and just we adjust and integrate. So then, if not separated, then we try for homogeneous function. Just by checking whether this function is homogeneous of 0 degree or not. If homogeneous function, then this is homogeneous differential equation, and we can solve it by putting y equal to bx, x equal to by, etc. We know. Okay. And if not separable, not homogeneous, and maybe homogeneous, maybe separable, but there is a particular form of linear differential equation. If we can write like this differential equation as a form, just like derivative, y is dependent, x is independent variable. This equation in y. So here y, and right hand side is equals to function of, just like this format, equation in y, y. If here x, then here y. Here dy by dx derivative of y is dependent variable, x is independent variable. If any particular differential equation of first order, first degree, we can write just like in this form, where p and q may be function of x, Clear? May be function of x, r function of x. Maybe q is function of x or not, but p is function of x. Maybe it may be constant. Also, it may be function of x. In general, we say that because 1 also can be taken as a function of x. So, any of these two, if constant, then we can also, if we can write like this format, where p and q are function of x, this independent variable, where p, q are function of x only, not y, function of x, where p and q are function of x only. Okay, then we say that this is standard form is linear differential equation of first order, first degree. Clear? Another form is like this, also dx by dy plus r x equals to s. Means here y, here x, here y, then function of y, r and s are function of y, where r and S are functions of y only. Okay, so this form or this form, this both form are a standard form of linear equation. If we can write equation just like in this form, R and S may be function of y. They are only function of y only, function of p and q and x only. This is called linear differential equation of first order and first degree. Linear differential equation. Okay, this is linear differential equation, first order and first degree. Its solution is very interesting. Its solution can be found. Suppose consider first. Okay, as similar fashion, we can find solution of the another form, that is this form. Okay, so this is, suppose this is differential equation. Okay, here dy upon dx plus py equals to q, where p is function of x and q is function of x only. Clear? Only function of x. If given relation is in this form, then its solution is given by the relation this differential equation in y. So value of y, so y multiplied by if equals to integration of q multiplied by if dx plus constant of integration. Its solution. Very simple. Where if, you have to remember this. If given equation can be written as this, then its solution is given by the relation. This is where if integration factor very important part of this equation. Okay, if integration factor, where if is integration factor, and this is equals to e to the power integration of p dx. This clear? P is function of x. If this any equation, if we can write in this form, what will be the value of p, that is in terms of x, function of x, maybe one constant also. P, if given equation can be written in this form, then its solution is given by this. In this equation, y is for this y, q right hand side, integration of with respect to x, c, and if in both places. What is if? Integration factor of the equation. Integration factor of given differential equation. How can you find integration factor? E to the power integration to dx. if. For this. Okay. For another format, just now you can first of all you have to find the value of if. Just write the given differential equation in this form and find the value of p and q and find if equals to e to the power integration p dx. Put value of p and solve it, get the value of if, write the solution in this form. Y into if, the value of if, here value of q, and write if, then solve this integral. That is the solution. C is the arbitrary constant. Clear? That is the solution. First test is write the equation in this form, get the value of p and q, write the value of p and q, and find the if, then its solution write in this form, solve this integral, you get the general solution. For this, dx by dy plus r x equals to s, if will be what? E to the power, if will be what? In place of p, sorry, e to the power in place of p, r. Now this is function of y, so r dy, integration of r dy, integration of p dx, integration p dx, integration r dy, r function of y dy, p function of x, integration p dx, integration r dy. So for this format, just if is this, and solution you can write in x. So x if equals to integration of s if and integration of y with respect to y and constants. Here y, here x, so x. Q is function of x, here q is s is function of y, so y. So this is method for this format. After this format, this is the solution. Okay. So whenever we cannot find the solution by using variable separable form, homogeneous equation, just like for testing homogeneous equation, then we can try for solution by this method. We have to try to write the equation in this format, or dx by dy plus rx equals to s format. Then we can get solution by this method. Okay, so this is a very important part of linear differential equation, so note down. Okay, now take exercise 9.6. okay, so there are 19 questions, so we will take how many times for this exercise? 2 class. Okay, because some of the questions I will solve and the remaining are for you. So here 9.6. So take question first. Okay. So solution 9.6. First equation. Given equation what? Given equation what is? dy by dx plus 2y equal to sin x. dy by dx plus 2y equals to sin x. Clear? It is not separable because we can write by transfer sin x minus 2y, not separable form. Also not, we cannot test for homogeneous. Okay. So another method we will find. So we know what about linear differential equation. We can see here y, and x is function of x, 2 only may be taken as a function of x. Okay, it is of the form dy upon dx plus py y equals to q, where p equals to 2 and q equals to sin x, which is linear differential equation. So its integration factor is given by if equals to e to the power integration of p dx. We know this is the format. So this is equals to e to the power integration of 2 dx. So we can solve it, e to the power 2 integration of dx, that is e to the power 2x, e to the power 2x. So if is equals to e to the power 2x. if equals to e to the power 2x. Clear? Therefore, we can write the solution of linear differential equation 1 as how? if equals to integration of q if dx plus c y e to the power 2x. Just put the value of if 2x here. Integration of q is what? Sin x into to the power 2x dx plus c. So this is solution. For finding value of this integral, just write, suppose y to the power 2ax is equals to I plus c, where I is equals to integration of e to the power 2ax into sin x dx. Now solve this integral. Okay, main thing is that now main thing is what? Solving this integral. How can you solve this integral? Now I equals to integral of sin x into to the power 2x dx. It can be solved by which method? Product of two function by parts. So here this is first function, this is second function, because exponential function second function. So here first function sin x into integration of this e to the power 2x dx minus differentiation of what? Sin x and integration of second function, whole is integrated by with respect to x. So this is e to the power 2x. So 1 by 2 e to the power 2x into sin x minus here sin x, derivative of sin x is cos x, 1 by 2 integration of cos x into e to the power 2x dx. Okay, now for solving this, again use by parts. This first function, this is second function. So here we see that what? 1 upon 2 e to the power 2x sin x minus e to the power 2x, first function 1 by 2, first function cos x, second function e to the power 2x by 2 minus integration of derivative of cos x minus sin x into e to the power 2x upon 2 dx. We get like this. Okay, so this is equals to e to the power 2x sin x minus half cos e to the power 2x 1 by 2, that is 4. Okay, so 1 by 4 cos x e to the power 2x minus minus plus and plus and minus 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 plus minus 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 1 by 4 sin x e to the power 2x dx integration. So this is equals to what? Half e to the power 2x sin x minus 1 by 4 cos x e to the power 2x minus 1 by 4 I. I means this I. Means same. This same. So we get like this. I equals to this. Clear? After this line we can write one by 4 I. So I plus 1 by 4 I. 1 by 4 I is equals to e to the power 2x by 2 e to the power 2x common by 2 common also sin x minus, or we can take common 4. Take common 4, then here 2 sin x minus cos x. Clear? So here just see 5i by 4 equals to the power 2x by 4 to 2 sin x minus cos x. So here we see that I equals to e to the power 2x upon 5 to sin x minus cos x. This is the value of I. Okay, now put here. Suppose this is equation 2. Okay, so this is the value of I. Now you can substitute this value to the equation and get the solution. Okay, so here now from equation 2 and 3 we can get this is 3 y e to the power 2x equals to I, means this e to the power 2x upon 5 to sin x minus cos x plus c. So this is the solution. You can write it in simplified form. Okay, e to the power 2x, e to the power 2x maybe cancel out. So y equals to 1 by 5 to sin x minus cos x plus c e to the power minus 2x. Okay, so solution of 9.6 first question. Yes, so this is the solution. Means main thing is integration on the right hand side. Y to the power if equals to integration of q to the power if plus dx. Integration is main part. So this is the solution, which is required solution. So remember, for solving differential equation, integration is main thing. So just practice for doing integration. Okay, very important. Chapter integration. Chapters, I think 7. Chapter 7. So this is the solution of question 1. Okay, we can solve one by one. Just like see here, equation 2 dy by dx 3y equal to e to the power minus 2x. dy by dx plus 3y. So take, suppose question 2. dy upon dx plus 3y equals to e to the power minus 2x. This is the equation 2. Question 2. It is in the form of dy upon dx plus p what y equals to q, where p equals to 3 and q equals to e to the power minus 2x. Clear? So same type of equation, same type of method will be applying here. Okay? Clear? So how can we solve it? Just find integration factor if. What? E to the power integration of p dx. This is equals to what? E to the power integration of 3 dx. What? E to the power 3x. E to the power 3x is if. So its solution is what? Y if equals to integration of q if plus constant. Integration with respect to what? X plus constant. This is the method framing. Okay, very simple. If e to the power 3x. So y e to the power 3x equals to integration q e to the power minus 2x e to the power 3x dx. Here integration is very simple. Solution is very simple. Y e to the power 3x equals to integration e to the power 3x minus 2x plus x dx plus c. So our solution is y equals to y e to the power 3x equals to e to the power x plus c. Just you can write also here y equals to divided by e to the power 3x. So e to the power minus 2x plus c e to the power minus 3x. This is the solution. Okay, the question solution of 2 e to the power minus 2x plus c e to the power minus 3x. Clear? This is the solution. Okay, so very simple. Third question, y by x square. So here y by x, y upon x, and here x square. Question third. Clear? Just like this. These are different things. 1 by x, here x square. This is question third. It can be solved also easily. You know what will be the solution? Just do it. How? Integration e to the power. This is equals to e to the power. E to the power integration of p dx. E to the power integration of 1 by x dx. E to the power integration of log x equal to x. You know, a equals to e to the power log a. We know this. A equals to e to the power log a. E to the power log a equals to a. So e to the power log x equals to x. So if equals to what? X. Therefore solution is what? YIF. YIF equals to integration Q IF dx plus C. So y IF means what? X. XY equals to integration Q means what? X square into X dx plus C. X cubed, x to the power 4 by 4 plus C. XY equals to. Okay, we can write solution like this. Also 1x can be cancelled out, but you can write answer in this form. Okay. Similarly, question 4, sec x tan x. Question 4, here sec x. Sec x, y equals to tan x. X lies between 0 to pi by 2. This is equation. Sec x tan x. Okay, sec x tan x, 0 to pi by 2. So, it can be also solved by this method. What is P? Sec x, Q, tan x. This is sec x and this is tan x. So, it is your integration factor. It is your IF. IF equals to what? You can find IF equals to IF integration to e to the power integration of P dx. That is e to the power integration of P. P means what? Sec x. Sec x dx. We know what? E to the power integration of sec x means log sec x plus tan x. Log sec x plus tan x. Integration of sec x, log sec x plus tan x. Okay. That is sec x plus tan x. Since a equals to e to the power log of a. This is IF. So solution is what? Solution is what? Y sec x plus tan x. Y into Ix. Y integration factor. Integration of what? Q. Q means tan x into IF means sec x plus tan x dx plus C. Now you can do it. How? Sec x tan x dx first integration plus tan square x dx plus C. So integration of sec x tan x equal to sec x, because integration of sec x is sec x tan. Differentiation of sec x is sec x tan x. So this is sec x plus here integration of sec square x minus 1. We can write tan x plus C. The solution will be what? Sec x plus integration of sec square x tan x minus x plus C, and left hand side y sec x tan x. Sec x plus tan x. This is the solution. Okay, you can check it. Question 4. Clear? This is solution. Similarly, this is the question 4. Was question 4? This is question 4. Okay. Now question 5. Question 5. Take question 5. Cos square x dy upon dx equals to tan x plus y equals to tan x. Cos square x dy by dx plus y equals to tan x and 0 less than equal x less than pi by 2. Clear? So here also we can write it how? Divide this equation by cos square x. So dy by dx plus 1 upon cos square x y equals to tan x upon cos square x. This is can be written as dy by dx plus sec square x y equals to tan x sec square x into tan x. Okay, we can write like this. That means when given equation is in just not look like this format, form of just not look like dy by dx plus py equals to q. We are trying to write that equation in terms of in the form of this, by dividing, by multiplying, by adjusting some. Well, here we see that here y, here only y, here tan x, here cos square x. So divide by cos square x, we can cos square can be removed from here by dividing, then we can get dy by dx just like this, plus of y into something 1 by cos square x function of x. So this is p, and here total function is x, that is q. So we can write like this, tan x by sec square x tan x and sec square x, this in the form of this, where p is equals to what? Sec square x, and q equals to tan x into sec square x. Okay, now you can solve it by standard form. Using standard formula if, first of all you have to find if, and then just write solution. Okay, so its if is equals to e to the power integration of p dx. So e to the power integration of p means what? Sec square x dx. Integration of sec square x is tan x. Sec square x, integration of sec square x. Derivative of tan x is sec square x, so sec square x is tan x. So e to the power tan x. So if is e to the power tan x. If is clear. Therefore, solution can be written as what? So its solution is can be written as y if e to the power tan x equals to integration of q tan x sec square x e to the power tan x dx plus c. So this integration can be solved just like tan x e to the power tan x sec square x dx plus c. Just put tan x equals to t implies sec square x dx equals to dt. Okay, so we can write sec square x dx, this is dt. So integration t e to the power t dt plus c. Now we can solve it by parts. So this is equals to what? First function t, second function e to the power t, e to the power t, e to the power t, minus integration of derivative of first function t1 into e to the power t dt plus c. So this is t e to the power t minus e to the power t plus c. So this is y e to the power 10x equals to, now 10x, t means e to the 10x, t means 10x. So solution is what? After this line, y e to the power 10x equals to 10x e to the power 10x minus e to the power 10x plus c. So here except one term, all the terms having e to the power 10x, so divide by e to the power 10x, y equals to 10x minus 1, 10x minus 1 plus c e to the power minus 10x. This is the required solution. Okay. Which is the required solution. Clear? So you can see the solution also 10x minus 1 c e to the power minus 10x. Sorry. Clear? So this is the solution. That means after writing the solution y if equals to integration of q if plus c integration q if, that is the main part for solution, because first of all you have to write in the standard form, then find if, then put in the standard solution format, and remaining thing is what? Doing integration. So practice, more and more practice, do the more and more practice for solving integration. So here we can you can solve also question 6. Just I am giving here hint in short. This is the solution. This is the solution of question 5. Now 6, 7, 8. Just I am giving hint to you, and you have to solve in your copy in detail and write or presentation of your solution should be effectively. Okay, so write answer in the proper way. Clear? So here question 6, just I am giving hint. Question 6, what? X divided by dx plus 2y. X divided by dx plus 2y equals to x square log x. X square log x. This can be written, if you have to write, if you write divided by dx, then you can see it is not separable form, not homogeneous. So here just dy by dx, so y, and remaining thing is x. So we can convert it how? By dividing only x plus 2 by x into y equals to dividing by x, here x, 2 by x, here x by x means x log x. Clear? So here we see that y, this is p, this is q. This is p and this is q. So if equals to what? If, it is our integration p means p dx means it is our integration 2 by x dx means what? E to the power 2 log x means e to the power log x square means x square. Since a equals to the power log of a, if is x square. The solution is very simple. Why? X square equals to integration of q. Q means this, x square into log x into x dx plus c. Now you can solve it. Clear? This is question 6. 7 x log x dy by dx. 7 x log x dy by dx, x log x dy by dx plus y, x log x dy by dx plus y equal to 2x log x, 2x log x. Here also you see that here y and remaining are function of x. So you can convert it in the standard form. What? By dividing. dy by dx dividing by log x, x log x, x log x. Okay. So here dy by dx plus 1 by x log x into y. Here 2x log x upon x log x. So log x cancel, 2 by x square log x. This is q, this is p. This is p means if will be what? You can also find here if. E to the power integration of 1 upon ax log x dx. For solving this integral, what? Log x equals to t. Then 1 by x dx equal to dt, dt by t, log t. E to the power log t, t means e to the power log x. So this is equals to log x. Log x equals to t, then 1 by x ds, dt by t, log t. Integration log t. Log t means log x. E to the power log x means log x. So if equals to log x. And solution is what? Y into log x equals to integration of q, 2 by x square log x square dx plus c. So log x equals to t. Then you can get value 1 by x dx equals to dt. So t square and here x square dx. So question 7, 2 by x divided by this log x cancel. So here not log x cancel, 2 by x square. So 2 by not log, 2 by x square into log x. Okay. Now this integral you can solve by taking first function and second function. Okay, so do it from yourself. Now 8. Question 8 is what? 1 plus s square dy. 1 plus x square dy plus 2xy dx. 2xy dx equals to cot x dx. Cot x dx, x equals to not 0 because we have to divide by x. I think here x equal to not 0 means what? Cot of 0 will be infinitive, tan 0, 0, cot 0, infinitive, so x equal to not 0. So here we can also see by finding value of dy by dx. So here dx is dx. So we can write 1 plus x square dy equals to cot x dx minus 2xy dx. So here cot x minus 2xy dx. Or here 1 plus x square dy. So we can write dy by dx equals to cot x minus 2xy upon 1 plus x square. It is not separable form and also not homogeneous equation. So we will try for linear differential equation. So here we can see that y and single term y and all are x. So we can write like this: dy upon dx equals to, separate it, cot x upon 1 plus x square distributed minus 2xy upon 1 plus x square. And we can write dy upon dx plus 2x upon 1 plus x square y equals to cot x upon 1 plus x square. Clear? So this is the standard form. This is p dy upon dx plus py equals to q. All function, q is function of x, p is also function of x. Linear equation. P is what? 2x upon 1 plus x square. So if is equals to what? E to the power integration of 2x upon 1 plus x square dx. If we put 1 plus x square equal to t, then 2x dx will be dt. So dt by t log t to log 1 plus x square. So e to the power log 1 plus x square. So this is equals to 1 plus x square. If equals to 1 plus x square. The solution is what? Y into 1 plus x square if equals to integration of q, this cot x upon 1 plus x square into 1 plus x square dx plus c. So here this cancel. So integration of cot x plus c, and cot x, integration of cot x is equals to, and you can solve it. Okay, the question 8 and then question 9. 9 can be also solved by adjusting, taking common y. So 9 can be also solved just like this. See, how can you convert 9? 9 means x dy by dx plus y minus x. X dy by dx plus y minus x plus xy cot x equal to 0. Xy cot x equals to 0 and x equals to not 0. So you can also see here y single time. How? You can take common here. X dy by dx plus, can take common y 1 plus x cot x. Here y, here y common. So 1 plus x cot x equals to x. Transfer x on the right hand side. Okay. Now divide it by x. So dy by dx plus 1 plus x cot x upon x, this, into y equals to 1. So here this is p and this is q. So you can solve it. Clear? 1 by x cot x integration and 1 by x log x. So you can get if and you can write solution. Now question 10, x plus y dy by dx equal to 1. Okay. Now question 10. Question 10 you can also solve what? X plus y dy by dx equals to 1. So here we see that if we write value of dy by dx, so we get 1 upon x plus y. So this is not in any of the form, not separable, not homogeneous. So y is in numerator. So just revert it. Dx upon dy. X plus y upon 1. We can write like this. Now this is another form of linear equation. Dy by di minus x. So x equals to y. You can write like this. So this is equals to what? Dx upon dy plus minus 1 into x equals to y. This function, this is r, this is s, that is r is function of y, minus 1 can be taken as a function of y, and y, s is function of y. So it's if it is the integration ry, it is the integration minus 1 dy, it is the minus y. So it is the minus y is if. Clear? So solution will be what? Solution y into if means it is the minus y equals to integration of sy into it is the minus y. Clear? Y to the minus y. Y to the minus y dy plus c. Now you can solve it. First function, second function by parts and then get solution. Similarly, 11 y dx x minus y square dy. Question 11. Question 11 can be find how? Y dx x minus y square. Y dx plus x minus y square dy. X minus y square dy equals to 0. How can you solve it? Try to find dy by dx equals to not homogeneous, not separable. So here we can see that just write dy by dx. Okay. So dy by dx transfer to right hand side, taking here. So dy by dx is equals to minus y upon x minus y square. This is the form. Okay. So minus y upon x minus y square. Not separable, not homogeneous. And also not y, not a single. Here, just inverting it. Inverting it means dx by dy is equals to take inverse of this x minus y square upon minus y. So now we can see that dx by dy equals to just divide x by y minus minus plus y square by y means y. Just we can write like this. Y cancel, minus minus plus y. So here dx upon dy plus 1 by y into x equals to y. This is r, this is s. Okay. So second format for linear differential equation. Similarly, this is x plus 3y square dy by dx. X plus 3y square dy by dx plus y equals to y. Sorry, equals to y and y is greater than 0. This is given equation 11 or 12. Sorry, 12. It can be also solved by adjusting how? Dy by dx equals to not separable form. Just write dy by dx equals to y upon x plus 3y square. Not separable. Here, not separable, not homogeneous. So, just invert it. Dx by dy equals to x plus 3y square upon y. We can see that dx by dy equals to x by y plus 3y. So we can write dx by dy minus 1 by y x equals to 3y. So what? Dx upon dy plus minus 1 upon y x equals to 3y. This is r, this is s. Okay. So up to question 12. Just we have solve questions up to what? 5. And from 6 to 12 you have to do complete in your copy. I am just giving what? Hint. How can you solve it? Convert it and just use formula for solution of linear differential equation. Very simple. Just write in the standard form and then find if and write the solution, do integration, and you can get the result. Okay, with the arbitrary constant solution of differential equation. Okay, so send me at least solution of at least 3 questions for your attendance. Okay.